So since how we did the built in with the CD then was not recording, I would I would explain how we are going to do the CD. I wouldn't have explained it initially, but the how we are going to do the exit function, the command. But since the other one was not recorded, let me just explain it. So we also want to check, okay, if the user's input, first of all, how we are handling the user's input to check if their built-in is what? We are trying to compare it. Right? So we want to compare it, okay? We want to compare it, the string, the two strings. That is, we want to compare the CD to what? To the first token, the user, that is the user's first what? String. That is this ls. And then, not to waste my time, but since it's not recorded, let me explain the same thing with the exit. So if you have, we can, so if you have the user entering something like exit, what we want to do is that we want to compare exit with what? The user's what? Um, Input. And if it matches, we perform our operation, right? So in order not to cause any misleading statements here, this is what you are going to do. You are going to have an else if statement here. So else if the user's what input is matches exit, this is what we want to do. So if you are watching the recorded section, you obviously don't have any idea what we did here. So please follow this very much well, and then let me explain to you what happened. So you want to string compare and also take note of some things, right? We've made some changes, and then we are only writing the condition to as what, as a, how do I say, as the otherwise of what, of the forked process. So make sure that what, before you fork, your else statement is here, so that you don't end up forking the built-in commands too, right? So that is basically what we've done. So we want to compare the line argument to, that is the first, right, the first one, right? We want to compare it with exit. Okay, and then if it is equal to 0, right? If it is equal to 0, then it means its match is. So you can do two things here, as I said in the earlier part of the CD. You can either write a function that will cater for it, or you can equally um, write everything here. So what I said is that here we wrote a function for the CD, and then the implementation is in what? Built in .c, and then this is what it does. Right, so these are the codes, and this is what it does. It first checks for the user's argument. If it is null, then it means the user did not pass any argument to what? To their CD, and it sends them what? To the home directory, and that's what we use. We use getTemp to get what? To get the home environment variable, and then we check for edge cases here. Before we change directory to home, we wanted to make sure that what it exists. They actually have what, how do I say, home directory can actually be what, to can be accessed and be changed to. Else, if the user's what input, that is the first command, is not now, we want to change to the second argument they pass to it, right? And if that one too fails, we want to print error to what, could not change directory, right? So basically that's what we've done so far. So here is here is where you want to exit. So this is where you've got into. So is that someone with a question, or we can move on? We want to exit. If the user enters what? Exit. So we can also create a function called built-in exit. I'm creating functions for this because I want our codes to be so as short as possible, right? That is why we are using um function. So we have not implemented this function, but we are going to implement it just like how we did with what? Built-in.c. So what is our exit taking? Someone can help us. What is our exit taking as what? As a parameter? or an argument. Basically an argument. That is the first what? The first token. That is what? Zero. Right. And then it works on it. Guys, right? True or false? Okay, so let me say if we compare the first token with hesitant is the same. We don't need to pass the command tree technique. We will not need it. Thank you so much for telling me. Though no one told me, but let me assume because so this is what we will not pass anything to it. This will be our function. We just want to exit. That is our main focus. We don't want anything to do with the token and the user's input. We just want to exit the program. So I think it's best we leave it like this, right? So let's move to the implementation of what our exit what function. Let's go to our built-in file. Since we are returning void again, is void built in exit, right? And then we are passing nothing to it, so void. So let's go. What do we want to do? We want to exit our program, right? How are you going to do that? I think I want us to try something here, okay? When before we exit, there is a lot of things we can do, right? I want us to try them, okay? So before we exit the program, we can print something like um exiting shell, and I'll use printf here so that the user will know that what, though it is not recommended, it is just for us, we remove it later. Exiting shell, right? And then before, so let me just say exit, right? Exit with zero. Remember, always exit with zero because we do not encounter any error. The user is successful. The program, even though the user entered exit, it's a successful program because we successfully exit. So it's not an error that is making us exit. Right. So the conventions, I sent it to the group. Guys, you know what it means. So let's run our program. So the ideology is that our program is supposed to what? Print exiting shell and then exit. So let's run it and see. Okay. Why? I didn't go back to my directory. Yes. So let me clear the screen. Okay. So yes, we did not declare it in our what? In our header file. Very necessary. That is one disadvantage of always separating your codes too. You need to be declaring the functions you use in what? In your header file. But it's best. It's best because you don't have any problem with Betty. Yes. So I think what did I do? So yes, I've cleaned it. So let's run it again. Shell. Let's hope CD is still working. LS. So right, so our shell is working as expected. Now let's enter exit and see if our exit worked. So it said it printed exiting shell and it's actually what? Exited. So that is what it's for the two built-ins we talked about. I don't know if there is more to it that, but if there is more to it, like the env, the env when you enter env in our code. No, let me go back to our code. It works, right? It works. Um, because we are using get so I think okay. It's a command, it's supposed to work. So yeah, so let me clear and let me exit. um I don't know, we can just end it here. At least you have a fair idea, so you just implement the rest you want to do. Let me try something before it exits. I don't like the way it just exits just like that. Let's try and do something here. So we can say before it exits. All right, it can wait. It can wait for like 2 seconds or 1 point, like just like to make it feel more interactive. Please, it's not part of the project, but I just want to convey an idea. We can say it can wait or it can sleep, and then we can use um this function. I like using it very much. to write my programs, the sleep, right? So it makes your program more interactive because we don't want to just end, right? So let's say if the user enters exit, we want the program to sleep for about 2 seconds, right? So exit. So it tells you that exiting shell so that you can get time to read what is happening so that you don't, it doesn't just end just like that. So basically, this is not necessary, but I don't like the idea of our built in as it being that much small. So yes, so that is what is happening here. So let's try it again. The user, the person enters exit. So it prints for the, it waits for the person to read what is happening. Exiting show. I don't think the LS test suit will let us pass with this, but as I said, my code doesn't meet a lot of standards. And whenever it doesn't meet, like I'm not even paying attention to free memory leaks, which is a very bad at. Please, whenever you use a pointer, whenever you dynamically allocate memory space, free it. And then whenever you use things like string duplicate, string copy, you want to free. Yes. So I think in this function, we actually paid attention to that. But with this, we have not really paid much attention to it. And in our shell too, or you will end up like, let's say your code runs perfectly, okay, everything happen that's perfectly, and then sometimes the ALS test it is going to tell you that what your code, your program is running as expected is okay, but then you are going to check and then you are going to get zero on your intranet, and it's probably maybe due to the fact that you have not what freed memory leaks. You have not freed space you allocated, and then there are memory leaks in your program. So if time permits us, we'll go through that too. So I don't know, maybe tomorrow or today. Let's just hope. So we've handled what built in. So we've handled built in. Where is it? We've handled built in.
I have a question.
Okay, please ask your question.
Okay, so what if the user enters the command exit but it's not written correctly?
And if the user enters exit and it's not,
Maybe the spelling is not correct. We have
oh, okay. Okay, I get you. That is a very good question. So, if the user enters exit and the spelling is not correct, that is a very good question. So, this is what we want to do. I'm coming. You first test the shell you are trying to implement. When the user enters something like this, right? So let's say exit and they forgot the I, right? It's basically going to tell you it's a wrong command. It's going to suggest to you, right? So it says command AST not found. Did you mean? So it means that if the user misspells a command, our program should not treat it as what? ESIT. It should treat it as the other commands and tell the user that that command is not what? Found. And we are going to be implementing that. So let me run it for you to see. But our code here, I think we'll handle it here. So our code, it is going to tell it that what? Um, our code is going to tell it that what? File is not found in any directory. That is what our code is going to tell you. So you'd want to print an error to the screen. So let me say shell. So LMEST. Yes, it says file not found in any directory. When the right thing to be expected of us is us to print that command est is not um did it what did it say? It's not found. Yes. So basically, is your question answered? Hello. Okay, so I assume yes. So let's exit off of our show and then let's um work on. Yes. The first exit might not work because it's just like the other show. When you mostly enter the first exit, it just kills. I don't know, but I think yeah, when you are at a path, there are some path, it just kills some of the process. Like let's say there's a process running, it kills it before it exits. Right. So um you will be getting the same result. You might want to enter exit twice before it exits. So don't worry, it's basically the same thing as Shell does. Okay, so So let me deal with, let's print your question. Let's work on your question. If the user enters a command, we are now in built-in. So if the user enters a command that cannot be found, or that, yes. So if the user enters a wrong command, right? What do we want to do? So we can do two things. In here, okay, we can print an error to the screen. So we can say that command, let me do this. That is if we are allowed to use printf, we can say command, and then we call for that. We know that we put a placeholder there. We say that, wait, what is wrong? I think I'm correct. So it's in what? It's in, let me see, LSL, LAS. So it is not, it's in a single quote. So you want to put that single quote in your what? In your function. Oh, you want to put that single quote. Basically, what you're trying to do is you're trying to follow what is happening, not found. But we will not handle it. And we will not handle did you mean, because these are mostly packages that are out in the system, and then we are nowhere near there. So we want to just print this command not found. Right. So let's go to our shell control plus. Okay, we'll also know where here clear. Why is take time, relax, good. So let's run it again. Okay, we did not pass any variable to it. What variable are we passing to it? Our command. That is the user's what? Input. So let's pass it. All right. So I think we are good to go. Shell LSL. Right. So it basically implementing what the shell does. Right. So it's doing the same thing. So yes, we've solved your problem. Okay. Are you okay now? I would. Are you okay now?
Yes, yes, thank you.
Okay, you're welcome. So let's see if the user enters. We say command this one not found. So yes. So um please don't use printf. Okay, yeah, let me type. Please don't use printf. Use, it's better to use write to write the error message. So what can we do about that? So please let me solve that problem too. It's not even advisable to what print this one here. So let's remove it. Right. Let me explain to you why. So we assume that, okay, if the command is not found, it returns now to the exec v here. And then now that it is returning to the exec v, so if the exec v does not get any program to work on, then only can we print that the command is not found. So to be on the safer side and more code wise, and yes, we would want to print that here somewhere where does execv field. So instead of printing execv field, we can print the command that field. So I think that one also not take. Let me. It will make the code plenty though. So please pay attention that this is not, we can't what do that in our function. We would want to rather do it in our what after our execv field. So let's say let's have another file that we can be using to print our error messages, right? So let's create another file here called error message, right? Error message.c, right? And then always remember to include your what? Include your header file, and then how are we going to call our what? Let me just implement it and call for it later. That way makes it easier for me to be able to know what I'm doing, or it makes it easier for me to implement what the function or what the function is actually doing. So if the command is not found, Okay, are we going to pass anything else to the functions implementation? Yes, we are going to pass the command to our function implementation. So if check if exec fails. So let's call for our function. We are calling our function error message. And what are we passing to it? Guys, we are passing the first what? Line argument. Because at this moment, this is our command, right? So we are passing this to it. So we are calling this error message and then we are passing you to it. So how are we going to implement this error message? First of all, we are taking the command. So let's go and implement it and do what we want to do with what? With the command. So in our file, void, we are returning, since we are returning void. So this is to print. Guys, remember that I'm doing this in different files so that our codes do not become error. This is to print the what? The error message, right? So we are returning void, but we're actually taking something. We are returning the arg. We can call it command here too. We are taking the command, sorry, as what? Yes, so I think my code is good to go. So what you want to do is you want to declare variables. Okay, so in case we are allowed to use printf, right? You can just printf or the fprintf family, right? You can just print it to the screen. But personally, this takes about 3 minutes. Let me use how you are going. Let me implement how you are going to be using the write to what? To print and to write an error to the screen, right? And then we've already talked about write. So first of all, in using the write to print an error message, you want to declare variables. You are going to have two messages. Please take note. You are going to have two messages. First of all, we are going to have the message containing the command, and then we are going to have the message containing not found. Why are we doing this? You understand. The reason why we are doing this is because the write does not support you using placeholders. So you want to be able to do different things and concatenate the two messages. It's like if you know Python, you know that the ideology is very simple. You want to concatenate two strings with the right? And then what you're going to use to concatenate is what? The absence of a new line. So they're going to be on the same line. So let's start implementing that. We want um to display. After this, we will touch on one basic thing, then we will just go. Time is almost up. Yes, okay. So let's display the error message. If you want to display the error message, that's what you are going to do. You first need variables here, but I like implementing before the. So let me just say the car error message because it contains a string, right? How did this one come here? Okay, that's a function name. Let me put first message here, and then let me say it's equal to the command in caps. Is it in caps? LSL. Yes, it's in caps. So the command here, and then you want to what? Terminate it. So you want to terminate it for now. We will come back to this. And then want to say that our second message can be. But before that, let's write this to this. Let's write this to the screen, right? So we want to write. Remember that we are what dealing with one. Guys, one right. I've forgotten it. It's one right. Is one.
Yes.
Yes, one. Yes. So you can write one here, and then if the numbers are hot, are messing up with you, you can just say standard error, right? File number, yes, they brought it there. So this is it, standard error file number. This also works fine. And you want to bring your message, this is what small, it is error message, right? And then what is the length? The length can differ. We are not going to count. So let's just let's just the length of it. Anyway, it is so the string length of So the string length of the error message, right? So yes, this does the magic. so so after saying the command, we want to print this one too. So the rest is actually, I don't know, it entails a lot. You would have to do a lot of things. Let me just copy this. Let me just copy this and come and implement it here. That is why I just want us to use printf in all the other ones, but I just want to touch on it so that you know you have a fair idea of how it works. So this place, we want this place to be the command, right? That is this one we took, the first argument we took from there. This command, that is what we want to print. So it will be the string length of what? Of our command. So, and then we can call this one to, I think C90 is going to forbid this kind of, but either way it's for practice. So let's just do it. I'll send it back. So we want to concatenate this command into the middle. And then right after that, so let me just bring one single quote here, right? So that it can have it in between. The command will be what? In between them. So everything is just a matter of strategy. They're not found. Right, and they want to bring a new line. If you are confused, please just use fprintf, or yes, fprintf to standard error. Any of the printf family, but I just want to touch on it. So let's copy this. Let's come and place it here. Let's paste it here. Let's copy this. Let's come and paste it here. Right, right. But this is message 2. So that we differentiate between it. This is message 2, no message 1. So message. So everywhere. No, I don't think we need it. We need this one. Let me remove it. So this is message 2. And a string length of what? Message what? 2. Right, right. So yeah, here is the most important part of it anyway. So in that case, okay, in that case, if the exec v failed, we want to exit with what? Failure. We just don't want to exit. So let's say we exit with what? Exit failure. Right. So I think that is all we can do here. So this goes. So remember that once we exit with failure, then it means our exec v is going to what? Return the child process that was encountered a failure. So I think that one was not really necessary. I wanted to know when the exec v encountered an error, right? So this is going to go back and affect it. So let's say this is what? This goes back to the exec v, right? So we are good to go. Let's compile and no. It means we've done a lot of double exiting. We want to remove one out of it. Our main program right after exec v, free line exit 1, or we should exit okay. I guess so. I guess so. Right now, just go on and execute the program and let's see. Please, I'm about to do that. Yes. So I just want to be sure. Okay. Yes, 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 yes. Let me see. Let me see. Yes. So yes, basically. So clear. And then let's work on that. Okay. Yes. Why didn't you guys remind? Why are you guys so quiet? No one even reminded me that I talked about the misdeclaration. So let's copy it and then let's remove this. Guys, please try and participate, okay? So this is for the first. So this is for the first one, and this is for the 2. So yes, we are good to go, right? Okay, error message. Okay, okay. Our function. Void message command. Copy. Put it in your header file, right? So you have this. You have this, so good. I think you shouldn't have any problem with us now. Good. So let's run our program. Let's execute it once more, and let's try and enter a wrong command, and let's see what happens. Oh, what happened? This is a wrong command. SEST. Okay, so definitely something is wrong. Let me list it and see. Okay, let me see. Um, Close, run, EST. All right. So it will definitely be from our built-in. Right. Let's go and check it out. Sorry, our get path. Right. It returns now if the executable is not found. Okay, and then what does it do with it? Let's go to our shell. It's supposed to affect this, right? It's supposed to affect it. So three args and then a line and then exit with one. So our function declaration. What are we not doing in the error message here? Exit with failure. Why is exit with failure not? Guys, what is wrong? Exit with failure. So it goes back to our shell. I'm trying to trace the problem right now. So this is obviously when exec v fails. So then it should print something to indicate that it failed or something. It should print command not found. Yes, anyone wants to say anything? Why is our program not running as it's supposed to? So let's
Um,
quit, clear, record for error message. It's taking the command line. So error message. Oh, okay. I think I'm getting it. So it takes this. So okay. So then our path search should not return now. Yes. So that is it. If we are trying to, if we remove the condition from here, then our path set should not return now. It should return the command so that it leaves the command for this function to work on. Right? I don't know if that makes sense, but you should understand. But we need a command again. So we will return command. So yeah, I think that is what is giving us the problem. So right now, what you are doing is you are returning the command back to the function. Right? That is if it fails. It needs it. We shouldn't return now. At this moment, this one became now because we are returning now if execv fails, if the file is not found. But when we return it, then we go back to the error message and we use it and we print it. And so that's why our code was not working. Let's run it again. I think. So shell, and then let's enter any Gabriel's command. We miss I. So yes, command not found. And as you can see, it is what saying our child process exited in non-zero status, meaning it has affected what our child process. So um that is the basic ideology. That is it. So to signify that the exec v failed to execute, so let's enter another thing and see. Yes, so that is it. But if you enter a command that works, it just prints it. So let's clear the screen and let's exit our shell. So that is all for printing the command not found. So I think this is a good ideology, but if you don't want any, I don't know, it depends. If it is accepted that you can exit, you can print that the command is not found whilst you're searching through it, or you can come and print it when execv fails. I don't know which one is better, but for to me, it's safer to print when the execv fails. Right. So you decide. You decide. So yes, that is all. So let's move on. Time. Wait for no man. So any question? Any question? I want us to do. I want us to handle one signal because we may not get time to go. So we will handle signal handling. I talked about signal handling in the previous videos. When I was starting with shell, I say one of the things you want to do is what handle signal. So signal handling. So any question? Any question? Anyone does not understand anything? Okay. Yes, yes. Question. I like questions. I like it when you ask questions. Please. Hello? Hello? Okay,
Hi,
then.
we're there.
Okay. Please, if you don't have a question, can you mute yourself? If you have a question, can you ask?
Cyprian.
Is that? Okay, so let me just find. Please, can you mute yourself? I don't want to. Let me just find the person.
Hello, guys.
Yes, Mark. Hello, Mark. How are you?
Yes,
Hello,
good,
Mark.
good. Um, I'm following so much closely. I'm following so much closely. Very nice presentation so far. So I'm like, I just need to find a way that I can put my head around the simple shell space because I'm following and then I'm missing some spaces. So I'm really trying to catch up pretty well. So just a quick one.
Okay, sure.
While working with ALX,
Uh-huh.
uh, like like the function we've just worked on, are we to build individual files for every function, or is it? Do you advise that we be updating the main the main shell file shell.c? Will you advise to have one huge file or several pieces of them? I don't know if you really understand.
Yeah, I think I get your question. What I would advise is okay, because of Betty. Okay, one person here, one person. I don't know if she joined the meeting. Yes, I think my partner also knows about that. Okay, so let me talk about she is here. My partner is here, so she is here. So let me talk about something. Okay, so I don't know if the other person joined here, but um the reason why is for me personally, okay, I advise that you separate the not necessarily the codes, but your implementations in different files. Let me explain. So when we started, I touched on a lot of things that we are going to be handling. If I were you, I would just handle every point in a different file. So in when I want to get like when I want to look through my codes, it should be in a different file. When I want to fork, it should be in a different file. When I want to do this, so you can get as many files as you want. That one is better than what your own your all of your codes going into what one file, because it makes it a bit difficult. It doesn't promote readability. Already C does not have a very good thing with when it comes to readability. C is very poor at it. You are not able to understand codes well when it comes to C, because some of the things are a bit complex. So personally, I would advise that, let's say you can have a file, like let's say a file to be taking your prompt, a file that you are going to what write the codes where you are going to be taking your prompts in, and then you put all of that inside. A file where you are going to use to get your path. All right, then it's also there. You implement it. A path where you are going to what, a file where you are going to get what your command. You are going to take the command get command or something like that, and then you want to use the get line to get the command. So if only, and then it makes it easy for you to even structure the while loop and the declarations well. So the only thing that will be in the main file will be what you just calling for functions with some basic things that you can do, like use string comparing. It makes your code easier to read, so that you see the way I was tracing the error, the way I was tracing the problem. I knew where to go because I have divided them into files, and I know which file is handling which what aspect of the code. So it makes it easy for you to be able to
Yeah.
keep track of what of your post or your progress. If there is something wrong with the path, I know that okay, let me go to the get path file because it is definitely there is something not going on well. You go through, you want to go through your shell. If there is something wrong with it, you want to go through. If there is something wrong with your built-in commands, you want to go to your built-in file. So that one is best for yourself, for future your future self. It makes it for you to be able to read your codes, you add comments, but if your file contains one file contains all of these codes, right? It makes it difficult. Like let's say
Yeah.
probably you have comments, but it makes it a bit difficult for you to keep track of everything when you get back to it. And also one last thing, Betty, right? So let me run Betty on my shell for you to see my shell does see that contains more than 70 lines. Let's run Betty. I just installed Betty recently, so I wasn't using Betty initially because this is a new PC. So as you can see,
Wow.
I have this error. I have more than 70 lines in what? In my shop because I'm having a lot of
Yeah.
codes, right? And then the reason
Yeah.
I was checking for the girl, I don't know if it's a girl or a guy, but someone tested me today to how to get rid of this what this problem, this Betty, so that you'll be able to pass Betty. And it is
Yeah.
funny, but I don't know whether it is a hack or anything. My partner and I did it and it went. You would want to, what she said she did was that I was going to explain to her how she can what separate it into different files, which was the best, which is still the best, right? But in case you've already done it, so what is the best way to move on?
Yeah.
You would want to declare I don't know, how do we say just declare the thing. I think her she declared something like just declare call for a function, any function inside your main. So I did not get time. So if I don't know if my partner is here or if the girl herself is here, she would want to elaborate on how she did it. So it's basically like let's say we want to void let's say we want to include a function that does not exist, right? And then we say void something like this. Obviously, this function does not exist. So let's see if it solved the Betty issue. That's what I'm thinking she did, right? All right. And as you can see, it actually solved the Betty issue. You see? So this is not a function that exists. You just if you've already done it and then you want your way forward, you
Wow.
don't know what to do now.
That's interesting.
Oh yes, very interested. Like let's
What's
What?
that?
I think I think it's a bug. It's a bug in the Betty codes
okay.
that they haven't realized yet.
It
So
is.
basically, that is why when Cyprian was asking about Betty, I was like, he shouldn't worry, he should let us move on, we'll come back to it. Because um
Ah.
this one will be very easy to solve. This one, this some of these codes because we know how to solve as of now, we know how to solve trailing white space, making blank. So this one, you want to declare this and then let's say I don't know, but let me include it. Let me compile it and see if it doesn't give us an error. We just leave it there like that. Yes, it doesn't give us any error. So and then with the other one, so if you've already done it and then your codes are a lot, what
Wow.
you want to do is you want to guess use this means to what pass Betty, but you are not helping yourself. I saw Betty's tweet on Twitter. She said whatever you say about me, I hope you become a good programmer. That is it. Whatever you say about her, if Betty is wicked, if Betty is whatever you say at the day, she has helped you. It was on her official Twitter page, and then she tweeted it. So, let me try and do something here. So I want to show you something here. So right now you can see we have like let's say some few errors left. So this this one was my partner. She helped us come up with a certain code you can use to fix trailing white spaces and missing indentation error and a lot of things. It just restructures your code. I used it. So let me go back to our simple shell project. So the few ones we have left, I think we can use a command to solve it. So shell project. I think it only works in V. That is the only reason that makes me want to use V. Aside that, I stopped using V. So you want to press escape and enter the command mode, right? And you want to enter JJ, that is enter JJ, and then you want to hold shift and then press VJ. right? And then you want to press equal to. Then it restructures your code and then it fixes some of the indentations and everything. So let's go and see. So I'll send the command into, or my partner will send it and then she will explain what it does. So let's check Betty here. All right.
Please, can you come
You said?
with the command you say? Sorry? The command you just did with V
Yes, it only works in V. Vim, yes.
to format the code. Sorry.
Yes, to format the codes, right?
Yes. Which command again? Sorry.
Yes, I will send it. Is JJ Virgin equal to, you want to enter into escape control mode and escape. First press escape. Press JJ, that is small j. It basically sends you to the first start of the. So if you are somewhere here, right, and then you press escape JJ twice, it sends you to the start of it and want to hold a shift. That is to get capital, just and turn on caps lock. And when you enter J Virgin, sorry. So let me start again. So JJ caps Virgin. Then you press equal, the equal to sign, and it restructures your code for you. So if you have something like misleading, um, how do I say, guards, like your open brackets and your close, they are not matching. Once you do it, it just puts everything in the perfect. No matter how messed up your code is, it just restructures everything for you. So yes, that is it. I think these ones, we can solve it when we want, but it's not really necessary now because we are not going to be submitting this code. It's just for the PLD section. So please, the person who asked the question, are you okay? Are we good to go? Time. We need to do one last thing and we leave here. Like 10 minutes. Are we good to go? So great. I
So
think
hello. Sorry.
Kabisa, Kabisa, let's move. Let's move.
Okay, I've sent the
Sure.
commands into the
Thank you.
group. So
okay. So thank you very much. I'll send the V command for restructuring of codes into the group. So thank you very much. So let's touch on the last thing. This one entails a lot, and because of time, so I'll just touch on and the when signal handling. I've explained signal handling one of the in our sessions. Like let's see, how is your shell able to interpret commands like control plus C, control plus D, and then yeah, so those things are, that's what signal is, right? Yes. If you press enter, yeah, the signal you send to your shell, right? Wait, I was about to close it. So we have control plus C here, right? So how is the your program able to tell that this is what control plus C, and then control plus D? How is it able to tell? Yes. So that one with the, I'll handle the control plus D since it's very easy and simple. Then we call this meeting of. So if you in one of your tasks you see something like end of file, right? Say handle end of file. So that is what you're about to do. So this end of file, right, has to do with how should I say it? Yes, you've come to the end of a file. After every stream ends, right, it reaches after every stream reaches an end of file. It's like the end of file is like the terminating statement for a stream, like not a line, a stream, right? So where are we getting our stream from? The standard input. So we want to trace our code back to where we are getting the standard input and we want to implement it there. So this is what is going to happen in this error reading statement, in this error reading input statement. That is where we are going to handle our our end of file because they are basically the same thing. How should I explain it? Yes, let me say they're basically the same thing, right? If you press Control plus D, if you press if you are not able to read the inputs, right? So if the person press Control plus D, we want to handle them here. Let me just start implementing because of time. So when the user presses, all right, okay, yes, when the user presses Control plus D, first should the shell do? Let's see for now what our shell does when someone enters Control plus D. Time, Control plus D. Yes, so error reading input, and it tells us that what success. So that is what we have here. Error reading what? input. But we don't want it to be that. Okay, we don't want it to be just that. Okay, so let's change it. Okay, guys, let's change this. Or let's write an else statement for it. Right. So when the person presses Control plus D, we can write an else statement for it. So let me just write an else statement for it. Right. So let me put an else here. My PC has become slow. I think it's time. So we want to put an else statement here. That means if it is not Control plus D, it should still print the error because we still need it. It's an edge case. So let's bring this so that we don't have any problem with misguided. Good. So your code goes here, your condition goes here. Good. Thank you very much. That's why I like VS Code. So let's type. So end of file is basically what? EOF, right? But let me use FEOF, right? They are the same thing, but they are not the same thing. They're like the same convention, just like exiting with one and exiting with two. They do the same thing, but they're not the same thing when you go into details. But this is what I practiced, and I didn't really go much into the end of file because I knew we would have to implement it. But this is what this is where my knowledge reached. So let's use FEOF, right, for the end of file. And I want to say that what, right, standard input, because the stream is what, standard input. So if the stream reaches what, end of file, right, that is if the user presses Control plus D, then what should we do? I think we know what we will do, right? Um, when someone presses Control plus D, let's see, Control plus D, yes, it exits, right? It basically exits, but I'll not exit here. Let me go here. Let's press Control plus D, right? It exits, right? So we would want to implement the same thing we did with what when the user enters what, exit. So let's just go grab our codes. No, not the error message. Wait, where did we built in? Right. So we want to print this, we want to copy these codes, and then we want to put it when the user also enters Control plus what, D. Right. So let's restructure this. Let's restructure this. Okay. So we really want to wait a bit. So let's say it will sleep for only 1.5 seconds. So that is what I personally want. So let's compile our shell. Sorry. You obviously won't see me pressing Control plus D here, but please trust me, I'm pressing Control plus D. So yes, editing shell and it exists. You want to print this also in a new line. So um so please trust me, I'm pressing Control plus D. So I think I ran, but either ways, so Control plus D. So yes, and we are good to go. So we've done a lot of things today. We've treated a lot of things. If you joined earlier and then you followed, you know that what we've typed most of the things every short program would do.
Can I ask a question?
Okay, please ask.
When you inside the end of file, instead of writing the code, could we not just call the function? Is it possible?
Okay, yes, please. Yes. Okay, let me do that. Wow, that's very smart. I even forgot we have a function for it. Right. So let's see if our function will work like it. Thank you very much. Okay. It means you are really following what we are doing. What is our function? It's built in exit. Right. So built in no, there's not a function. Built in exit. We don't pass anything to it, so is that correct? Okay. All right, sure. So Control plus D, yes. But remember that our function is not doesn't do it on a new line. So you can equally what go back to your function and then implement that if you want for it to be on a new line or anyway. It all depends on you. Shell, just customize your shell the way you want it. Right. So for now, I think that is enough. We've learned a lot today. So let me try and let's work on our shell for so far. Let's see what our shell is doing. Um, thank you very much for for bringing my mind to it. That was very smart. So let's see what is happening here. All right. We are coming to test our shell overall. We will not get time to. I know I promised this the ALS test suite. We are not going to use it. Obviously, it's not even going to go for our codes because we have a lot of things we are not doing the right way. So this is it. I've cloned it. I've tried to. Most people are complaining. I've tried to push it on my GitHub. I've tried to get the ALS test it and push it on my GitHub. So I'll think I'll just go through it how we use it and then I'll not touch it. A lot of things on it. So I have a lot of projects to do. Our simple share is not here. LS and then hello, is Calvin here? Calvin, are you here? I think he's gone to work. So yes, so let's list it. Calvin, if you are here, let me know. So let's run GCC flags, show no all C files, right? And then we want to say show, right? Um, let's make it HSH. That is how it is known with a compiler. That's how you'll be compiling your codes, right? All right. Instead of this thing always instead of oh I brought it there, right? So HSH. So let's test our show. Okay, okay, let's clear. Okay, so let's touch a file. Touch V. Let's list. Let's touch V here. Yes, V is here. So it's working. Let's make directory Vim. No. Emacs. For the Emacs supporters don't hate me for using yes, Emacs is also here. All right. We can equally implement to get the colors, but I don't feel it's necessary. So let's what else can we do, guys? What else can we do? What else can we check our shell to see? Anyone?
The CD.
Yes, let's see the into what our Emacs. Oh, we've not done handle tabs, right? So let's see the into Emacs. Okay, let's list. All right, so let's create a file here. Touch V. Let's list it. Okay, let's go back. Let's remove this file. We don't really need it. So remove V. Let's see. It's empty. Let's go back. Let's list. Let's remove directory V.
What of PWD?
PW.
D.
Okay. Okay, sure. It will work. It will work. Yes, it will work because we've handled yes, it will work. Just know it because if env works, then that one will also work. So let me clear the screen. I don't know if you guys saw something. I've not handled control. Like let's say if you press up, it will go to the previous command and everything. So let me try something like I was trying to do something. Remove V. Remove directory V. Okay, yes. So we have our child process, right? Printing, which is not what we want, right? We want it to just say that it did not know directory. So if you are following, you'd want to clean that part, remove it and print an error or anything. Aside the child process printing, we don't need the ID for anything, right? So, and I think this is because V is not a directory, right? Yes, it was Emacs. So let me remove directory Emacs. Yes, and then let's remove V. All right. So let's create Emacs again, and then let me use the R and remove from. Let me try this Emacs. I always forgot having tried this one. Let's see. All right, so let's list and see. Good. So our shell does Basic things, let's go to home. It does almost every basic thing every shell does. Let's go to the home. Yeah, no search for direction. Okay, let me just enter CD. That's how we did it. So yes, it does most every basic thing every shell does. So this is how far we've come. This is what we've done. Let's exit our shell. And then I'm thinking of that. Okay, we've done almost everything that every basic shell does. So I don't really see the relevance. Okay, so we will talk about you handle non-interactive mode. So I think tomorrow I will use tomorrow. Tomorrow I'm hoping that tomorrow will be the last day. Tomorrow's meeting, since if your short does all of these basic things, then it means you are good to go. You just have to use the ALS test you to check for the other edge cases. And the one I'm going to, you realize that we did not do some things. Please implement them. Like let's say, um, like non-interactive mode, right? We use the iSATI. We use the iSATI to check for non-interactive mode in a different file. So I'm hoping that tomorrow will be our last section, and then I'll use it to test how to do the ALS test suite. I promised the ALS test suite. So what you want to do is you want to clone time. Okay, so tomorrow, right? Please bear with me. Go to my data app. I have pushed it there. The instruction, the readme is not the person who created it did not really do the readme well, but you understand. And I will try and make changes to it for the readme to be very easy to understand what they want you to do. So you go to my data app and you try to what do that, and then so yes, that is all for now. And then in our next meeting, that is tomorrow, I'll try and dedicate time tomorrow to we'll handle non-interactive mode, and then we'll fix better, and then that will be all for sure. Right. So that is it for today. Any questions? Anything you have to say? Please realize that short goes way beyond it. Your question.
So far, where we are, have we handled like all the compulsory tasks?
Other one?
The compulsory tasks.
The composite. Oh yeah. Yes, we've handled so far. We've handled and control plus D, right? That is the end of file. So and then we've handled arguments. Yeah, so we've handled yes, we've not handled all of the compulsory tags, please, because I'm not even using I'm not allowed to share the intranet. So and I don't remember the last time I went there. So we've not handled all of the mandatory tags, but we've handled some of the what the advanced, that is the gets line, right? And then we've handled some most of the mandatory, right? That is why I can say we've handled most of the mandatory. If you have this, then you are sure that what your marks is secure that you are going to get above 70. I can say 75, 70. Yes, because there is more to show, right? There is more to show, like in situations where, like the non-interactive mode, like when we handle the non-interactive mode, then we've handled most of it. So let's say if the user enters, um, and the user wants to echo into our program, so he wants to say bin ls, or let's say just say ls, and then he wants to is this how it's done? Yes. Echo it into our show. What do we get? Okay, I think I'm not doing it right. So let me see. This is from non-interactive mode. Anyone to all pass. So let me use the file to illustrate it. Let me see. I would have to create a file. It's one of them. It's one of them. It's one of them. This is Echo LS and no. Let me see this. It's one of them, like non-interactive, but we'll handle it. Don't worry. Yes. Like when it's append, like let's say the greater than sign and this. So let's say and execute echo and execute. Let me see. All right. So yes, this is non-interactive mode. When the person passes a command, right, from what? From this shell into your program, what does it do? So let's say if the person passes ls into your program, right? This is what happens. So it means that this is non-interactive. Like let's say the person is passing commands to it not in your main program, right? So then, but that is not it. This is not it. It's weird. It's more complex than this. right? That is why I say I'll let us talk about non-interactive mode. So I think after that too, we will be good to go. But for now, yes, this is what is required of us in the basics. If you're able to do this and you understand what you're doing, you just have to go through the ALS test suite and handle the rest. The rest, like let's say if the test suite is expensive, we'll talk about it tomorrow,
You
right?
talked about that you were going to show us how to use a test suite today. Though I actually go through the repo and could not really, I try using it, but could not really dictate exactly the result it's really giving. It's running, but I could not really read through the
Okay,
results.
okay. So let me use it will take about 7 minutes. Let me use 7 minutes to touch on how you use the what the test suite. Let me clear. I think the instruction itself is not clear, but CD. So let's say wherever, let's say go to any, you can clone it anywhere. I wouldn't say anywhere, but anywhere. As you can see, I have it here. But let me remove it. Okay, let me remove it. Let me start again for you to be able to see how I'll do it. So git clone, right? HTTPS. You go and grab the link. I assume you already have the link. So let me just how do I say it? Let me just type it here, right? And then let me just grab it from what using the link in my head. So at github.com. Please, if I'm wrong, you tell me somewhere. So then my username is Santa Kobe, and then it's what? Simple shell. So this is me trying to grab it from my what? My GitHub. I wouldn't want to go to my account itself for, to expose a lot of my some private repo and everything. So yes, so this is me trying to grab it. Let's grab it. So if our cloning is done, let's see if we're able to clone it this way. Please work. Wow. Okay, so let's wait. Why is this taking so long? As my internet is connecting. Let me see. LS. Yes, it has been cloned as you can see. But I don't think it cloned everything. Maybe I interrupted it. But either way, let me see. I was not understanding why it wasn't coming. So let me just remove it and clone it again so that I just have to clone every file. Yes, so I have it here. So let me clear. So if you've cloned your the simple shell test suite from my GitHub, that is, if you grab this from my GitHub, you want to CD into your you want to you want to move this into where your shell project is. So mv and then the name of the repo, right? So I'm moving this repo, right? This test suite into my project, but I don't want that to be the case. So let me just copy recursively. I want to copy everything, right? And then let me try and find my path. So we are at C programming. So C programming. Don't worry, I'm just trying to find where this one is. So let me make it less complex. I've moved it to C programming. All right. So let's move it from here to copy recursively into our shell project. So copy this into our shell project. So yes, let's go into our shell project. This is how to use the test suite. So you have the simple shell test suite here. So from here, what do you want to do? Let me clear the screen. You want to enter into the repo, simple shell, and ls, right? And then grab this test suite, the directory called test suite. Grab it and send it to where your project is. So we could have equally done that. We must have this test suite in our program. So we are moving it back. What I'm doing is I'm moving test suite back, right? So I have moved it back. Let me go and see if it is there. Meaning I have no need for the repo itself. So let me just remove it. But just follow what I'm doing. You understand how it works. So remove simple shell, right? So ls. So you have the test suite here, which is good. Clear. So let's enter into the test suite and see what is there. It contains a lot of things, right? So you want to grab only two things from here. No, only one. But just make sure that what these files, this file and this file are executable. They must be in green. So if they are not in green, you might want to what change modification plus s, or you can equally be u plus s. Just make it executable. But to be on the safer side, let's this file and then what this file. So if you make it executable, now this is what you want to do. Move the run checker.bash to where your project is. Or yes, so move it run checker.bash to where your project is. Right. So it's no longer here. So go back again to where your project is. So your project must be something like this. Okay. So you have the run checker there. So let me clear the screen and ls. So you want to execute what? The run checker. If you want the ALS test you to test everything, right? You want to just run it like this or make some add this, or I don't know, maybe asterisk. I don't remember which one worked for me. And then, but if you want to specify on a particular tax, let's say you want to check if you've passed tax one, you just append one to it. Like so, you want to execute it with what? With a run, and then it starts going through. So let's see. So this is how it works. So you see, it says okay. The moment it says okay here, then it means you have what? You have passed that check. So what? So tax one, checker one has checked. Good. So the one that does not check, they tell you. So when they echo bin ls three times, this is what they got. They got it listing it 93, but they expected this. So then it means that you have to what? You have to check their expectations. What are they expecting? Okay, what is the checker expecting? And what did they get for mine? And what is mine doing? They want to compare. They want to find out the problem and solve it. So yeah, that is how it is. You will just be seeing all the errors. You just be seeing it. You'll be comparing it. It will just show you. So it gives you a fair idea of what of everything. So you can see from tax one, it will tell you the number of okay output is what is one, and the total is what seven. So out of seven, only one check, and it's not surprising because our code, our shell is not what we didn't follow a lot of rules. But if you followed me and then you followed the rules, you know what it's expecting, then you get it okay there. So if the tax one, I didn't check for the tax one. I didn't check. As I know, I still don't know what they're requiring. But if you mishandled any of them, it will indicate it there for you that this is what I was expecting I did not do. So it will list it, and then you look on that to make adjustments to your code. So that is how to use the test suite. So this is for tax one. So yes. So is it clear now?
Yes.
Yes. So that is how to use the test suite. So basically, that is the end of our meeting for